Hello everyone and welcome to your Chem 113 review on Electron Configurations. My name is Jason and I work for the ASU Tutoring Center. Now an electron configuration is essentially a streamlined version of that electron diagram that I talked about in the last episode. So it's a way to write out what orbitals are being used and filled for a particular atom. Okay? And how this works is I've provided a chart here. And this chart looks very complicated, there's a lot of colors going on. But it's actually a very useful way to write out the electron configuration of an atom. So the idea here is certain blocks are colored in like blue, and those represent sort of the quote unquote S block. So they represent S subshells depending on what energy level you are in. So each row represents essentially your principal quantum number, your energy level. So this is like the principal quantum number 1, 2, 3, 4, 5, 6, 7. And then each color represents the subshell within that, that primary or that principal electron, that principal quantum number. So for instance, in the one row, the only subshell you see is S, because the primary, I keep saying primary, the principal quantum number 1 only has an S subshell. But in the principal quantum number 2, you have both an S block and a P block, because the principal quantum number 2 has 2 subshells. You'll notice in the third one, you only have S and P, but you should also have D. We'll discuss that in the next video. The D block and the F block are a little weird, so we will discuss that in the next video. Here we're just going to focus on S and P primarily. So how you write out the electron configuration. So imagine you're trying to write it out for like, I don't know, let's say carbon. I mean, I guess we won't even do an example. We'll just do the silicon that was given to us, right? We're trying to find the electron configuration of Si. We're trying to find this electron configuration. So how you write it out is you start in the upper left. You start at hydrogen and you work your way through the rows, okay? So you start with the principal quantum number 1, and you start with the subshell S. You always start with 1S. And you just kind of go row to row to row until you run into the element you're trying to write the electron configuration for. So within this first row, I go hydrogen, I go helium, and then as I go to the right, I just end up going back to my next row. So essentially, I'm done with the S block. So I have essentially filled in the electrons for the 1s orbital. So I would write a superscript 2 here. So within the 1s subshell, I have filled up both of my electrons. And then I go down to my next row. So now I'm in the principal quantum number 2. The first thing I run into is the S block, so I'm in 2s. And again, I haven't hit silicon yet. So I just keep going through them. And I've used up both of my electrons in my 2s orbital. So then I continue on, I keep going through my row, and now I'm in my 2p orbital, or my 2p subshell rather. And I keep going, I keep going, I keep going. I don't run into silicon yet, so I've used up all 6 of the electrons that are available in the 2p subshell. Then you go down to your next row, and you start here, and you use up 3s, and you fill up those 2 electrons. And then you come over here and you can't fill up all 6 electrons, because as you start working your way through, you end up at silicon, which is what you're looking for. So within the 3p subshell, you only actually fill up 2 of the electrons. Because once you count 1, 2, you end up at silicon, which is where you want it to be. So that's the idea. You work your way row by row by row. As you finish different subshells, like the S subshells, the P subshells, as you finish them, you write them out. So I finished the 1s orbital, so I wrote it out with the 2 electrons that were in it. I finished the 2s, so I wrote 2s2. I finished the 2p, so I wrote 2p6 because there are 6 electrons. You just keep going and going and going until you end up at the one you wanted. So we ended up in the 3p subshell, and we only used 2 of the electrons, because silicon was the second one into that P block. So we wrote 3p2. So this is the electron configuration of silicon. Okay. Now, if you wanted the condensed electron configuration, what this means is you look at the element you're trying to write the electron configuration for, in this case SI, and then you go to the noble gas that comes before it. So the noble gases are in this column, in the very last column. So you look at the most recent noble gas that you passed, which would be neon. That was the previous neon, the previous noble gas was neon. So we would write neon like this, Ne, and we essentially imagine that we're starting at neon now, and now we start going through the rows again. So starting from neon, now we end up in this row. So we get 3s2, and then we go to the next row and we get 3p2. So essentially, by starting at the previous noble gas, you start at the last like full shell, right? Because we filled up the 1 shell, these filled up the 2 shell, but we didn't fill up the 3 shell. So what we did by writing out neon, we wrote the electron configuration of the first 2 shells we had. And then we just wrote out the rest of it that's left over because we didn't actually end up filling up the 3rd shell. We only filled up the first 2. Okay? So condensed electron configuration, you write out the previous noble gas in these sort of brackets, and then you write out the electron configuration for that row afterwards, leading up to the element you're trying to write the electron configuration for. Okay? So using the periodic table is typically the easiest way to write out electron configurations, at least in my opinion. All right, well, thank you for watching. As I mentioned at the beginning of the video, I work for the tutoring centers at ASU. If you want more information about the free tutoring services available at all 4 major ASU campuses and online, please check out tutoring.asu.edu/content/tutor-search. By going here, you will be able to find a tutor on your specific campus or online that can help you with your specific class. Thank you again for watching, and I hope you have a wonderful day.